Okay guys, so we're looking at section 2.4 part 4. We're still doing this chain rule. We have some examples. So sometimes when we're trying to do the chain rule and take the derivative, we have a problem like example 1 where there really are no parentheses given to us, but there are parentheses in the problem. Can you guys think of where there actually is a parenthesis even though it doesn't show it? Yeah, you're right. There's going to be parentheses around that 3x. There's also going to be parentheses around the sign and around the squared. So this problem is really the sine of 3x squared. That's what it actually means. So our outermost parentheses right here, those are going to be the u values. So we have to start off by thinking of this problem as u squared. What is the derivative of u squared? 2u. So I'm going to have 2, and I don't change that u. So it's going to be 2 sine 3x, just to the first. So now I did the derivative of u squared, so that's gone. So working inside now, what's the derivative of this? Now that's going to be our u. That 3x is our u. So what's the derivative of sine u? Cosine u. Don't change the u. And now times the derivative of that inside part right there. And what's that going to be? 3. And now I know I'm finished because I've done the derivative of sine, I've done the derivative of 3x, so we are now finished with the problem. So y prime is going to be 6 sine 3x cosine of 3x. Now, do you know of something else we could do with this? We did. Let's look at our formula sheet, our purple sheet. So if you look at the purple sheet under our double angle formulas, do you see how down here we have this formula for the double angle formulas? And it goes a sine theta cosine theta is a divided by 2 sine of 2 theta. We have to always be looking for this pattern. We always want to look at our answer and see, does it follow this pattern? We'll look back at what we had. Do you see how we have that pattern? So what is this final answer going to be then?
3 sine 6x.
Right, 3 sine of 6x. And that's going to be our best answer right there. Okay, now problem number 2 looks really similar. But it's different in that we're starting off with the 3x getting squared and not the sine getting squared. I like to put in all the parentheses just so we understand what the u is. That's actually what that problem means. So I'm going to start off by thinking of this problem as not u squared. Even though this problem looks very similar, this first step is sine u, because look at those outermost parentheses there. What's the derivative of sine u? Cosine of the u. So we just took the derivative of sine, working our way inside. So now we've got this part. So now we've got u squared. What's the derivative of u squared? 2u. And so we did the derivative of u squared, so now we did this, and then times, and what's the derivative of 3x? 3. And so now we're going to put all this together. So we're going to have y prime equals, and we're going to have 2 times 3 is 6 times 3 is 18x cosine. Oh, I didn't write that right. That should be like that instead. Cosine of 3x quantity squared. What's another thing you could have done at the very beginning? You could have just squared that whole angle. What would you get if you squared that whole angle? 9x squared. And you could have done the problem that way, and you would still have gotten the same answer. It's just that you have to be consistent with the way that you apply that rule, that chain rule. All right, let's look at example 3 now. Same thing, our angle is getting squared. So what are we going to do first then? Take the derivative of cosine u, correct? Because there's really another parenthesis right there. So our first step then is the derivative of cosine u. And what is that, everybody? Negative sine of u. Okay, so I did the derivative of cosine, so now I'm to this. How do I have to think of this? U squared, right. And what's the derivative of u squared? 2u. Okay, so now I did this derivative, and I'm working my way inside the parentheses, and what's the derivative of that part? Negative 4. Okay, and so now putting all of that together, we have a negative times a negative 4, that's positive 4, times 2 is 8, times 1 minus 4 theta, times the sine of 1 minus 4 theta quantity squared. Okay, now this next problem looks similar, but it's different in that, look at the location of the squared. Before that squared was on the angle, but this squared is not. This problem needs to be rewritten. This is going to be 1/2 pi. What kind of number, or what kind of expression is 1/2 pi? Is it a variable or a constant? It's a constant. 1/2 pi is just our constant. It's our k value. Then we have the cosine of 1 minus 4 theta, and this whole thing is getting squared. Sometimes just rewriting the problem is the hard part. So rewriting this is a little challenging because we've got to think, okay, this is what we would do first. Then we would take the cosine, then we would square, and then we would multiply by the 1/2 pi. So this would mean the same thing. Find the value of the angle, take the cosine, square it, and then multiply by the coefficient. All right, so now let's go ahead and take the derivative. So what is the 1/2 pi times the 2? What's that going to be, guys? Pi. So we did this part. We did the 1/2 pi times the 2. That's gone. Working our way inside. What's the derivative of cosine of something? Negative sine of that something. So we did the derivative of sine. What's the derivative of 1 minus 4 theta? Negative 4, good. All right, so then our final answer is going to be, we've got a negative 4 times a negative times a pi. That's positive 4 pi sine of 1 minus 4 theta. Did I take? Yeah, I did. Okay. All right. I feel like I did that problem wrong. Do you guys think I did that wrong? I need to redo that.
He does.
Yep, I did do it wrong. Let's switch over here again. I'll show you the mistake. All right. Here was our problem, guys. This is the same thing as 1/2 pi cosine of 1 minus 4 theta squared. On my first step, when I'm doing k times 2, that was going to give us the pi times the cosine of 1 minus 4 theta. That is our first step. I changed this too early. I forgot to write that. So the first step is doing 1/2 pi times 2 is pi cosine of 1 minus 4 theta. I forgot to write that u part. So now this is gone, and now I have to do the derivative of this. So the derivative of cosine is negative sine of 1 minus 4 theta. And so now I took the derivative of cosine, so that's gone. And so now I have to do times the derivative of 1 minus 4 theta, which is negative 4. So simplifying all of that, we're going to have negative times pi, and so that's going to be 4 pi, and then I'm going to have sine of 1 minus 4 theta, cosine of 1 minus 4 theta. And now do you see this pattern? A, sine u, cosine u. So what do I do with this? Divide it by 2, and then I do the sine, and what do I do to this angle? Double it, and double the whole thing. So it's 2 minus 8 theta. That's what the answer should be. All right, and that's a good example because that mistake that I made is a common mistake, and it's because we just forget to write that u down. When you do that k times n, you got to make sure you write down the u and then do the derivative of the u. All right, so let's change this. This is what the answer should be. All right, guys, let's try these last. Let me see if there's something else I'd rather do. Yeah, let's do these last two right here. All right, guys, in this problem here, what are we going to think of as being our u at first? Yeah, minus 1 squared. So there's another parenthesis in here. Okay, why don't you guys try it on your own? I'll be doing it up here if you get stuck. Let's see if you can do it on your own. Use your purple sheet as needed if you need to know cotangent's derivative. Everybody get it? All right, so if you didn't quite get it finished yet, just kind of look at the end of it here. So what I had to do was, once I had cotangent, that derivative was negative 2 cosecant squared of the u. So this now became u squared, so I had to do 2u times the derivative of u, and then just putting it all together. Anyone else get the same answer? Good. All right, let's look at example 6 now. This is going to be y equals, look at where the squared is. This is going to be 2 cotangent of 3x minus 1, and then that whole thing is getting squared. See, that's the thing. People have trouble understanding the difference between these two, but here's the whole cotangent of the value that's getting squared. This is like that number 4 problem that I accidentally forgot one step with. So let's see if we can do this the correct way. So first I'm going to do 2 times 2 is 4. I have to write the u. See, that was the mistake I made last time. I did 2 times 2 or whatever the numbers were, and I got that, and then I went on to the next step. I have to write that u. Okay? So I did 2 times 2 is 4, u. Don't change the u. I keep saying that about 1,000 times, and then I actually did it. So, all right, so we've got that. So now we did this part, working our way inside. Now we're doing the derivative of cotangent u. Well, the derivative of cotangent is going to be that negative, I'm going to sneak that negative out there in front, negative cosecant squared of u. And then times what? Times 3, times the derivative of the inside. So I've got that negative there, so it's negative 4 times 3. That's going to be negative 12. And then I've got my cotangent of 3x minus 1 times the cosecant squared of 3x minus 1. All right, makes sense? Not too bad, right? Okay, we're going to stop there. There are some more problems in the notes, but we'll do some of these on Monday just to see. We're going to have our quiz on Tuesday over the chain rule.